So for assignment 4, question 1, I've created the color selected 3D optimized shader. It's simply just passing the pre-computed worldview projection product and the color in a single buffer. And since it's pre-computed, we can no longer need to multiply the view and projection, um, the view world and projection on the in the shader. Um, and I created the classes, which is similar to the other shader classes, but just the associated constant buffer information is different. And the main piece is the send worldview projection dysfunction call, which basically pre-computes the world times the view, where that's actually the view projection product, which we can see here. In the draw, we're pre-computing the view times projection, and we're passing that to the shader to multiply the world times the view projection and the white color, of course. And then that gets sent to the GPU through upstate sub-resources and then gets rendered, and the result is exactly what we expected. Oops. So let me bring that back. So question 2 is basically the same as question 1, the same shader code exactly. The only difference is that we're doing 5 objects this time. So I created these 5 matrices and just put any coordinates, and then inside the draw scene, we're still pre-computing the view projection product, and then for each of the 5 objects, we send that to the method to do the final multiplication with the world, and send that to the GPU with the new color, and then we just do the render, and we get the 5 objects. So for part 3, we had to do the texture mapping onto the face of the pyramid. I would just go ahead and show the end result. So this was basically what I ended up with. And so I basically created 12 vertices, or 13 vertices, I think it is. So 4 for the base, and then 1 for the very top of the triangle, the tip. And that's for basically displaying the bottom face, but I had to, of course, make duplicate vertices for each of the points where the triangle face meets the bottom. And so I have duplicate vertices for each one of those, and then I used those to wrap the texture as expected. The only other thing of note is that in order to get it to look like the picture, I had to basically cut the UV in half. So I did 0.5 there, and so it gives the nice little triangle look going right there. Yeah, I think that's about it for that one. So for question 4, we had to again wrap a texture around one of the pre-made objects, this time a box. With this question, we were given this texture, and each one of these 4x4 represents one of the 6 sides of the box, and we have to properly get the coordinates proper to correctly map that texture onto the box, and the end result is this. So basically it's similar to what was done on the pyramid. We have to duplicate the vertices for each, basically each one of the vertices we have to duplicate so that each face can be properly aligned And since since the texture is divided by in basically eighths, then each one of the blocks is going to be 0.125 long, and so I basically just using that 0.125, I basically multiply by the number of um, of individual boxes, and use that as the point to find the point where the vertex should map to. Just took some trial and error, but so I basically just came up with this. Just simple 2D navigation, I guess. So question 5 was a pretty straightforward refactoring. I took the shader texture class that was given. I basically moved the texture in the constant buffer structure out of DXApp, it's commented out there, and into the header class. And inside the texture class, it's similar to the other shaders where we just pass the file name and do the custom input layout specific to the shader, do pretty basic setup. And they mostly work the same as before. One of the differences here is that I have a pointer to a texture, but I'm not managing it here. The texture itself, as I think you could probably reuse textures throughout the place, so you don't want to keep duplicating them. So it's just a setter, which is used when the setting to the shader is setting its context. So we call the texture one. It's pretty normal. Just declaring the shader and basically setting that texture pointer here. Draw is similar to it as it was. We set the context, do the camera stuff, and set the object's world matrix, and then render it. And that's pretty much it on that one. So the and the end result is basically I took question 4 as the base for it. So that's what that looks like. So for further work 1, playing around with the textures and applying them, basically we end up getting something like this. And this for test 2 and test 512, they are both red, and crate face is all brown, and that's because since we're using a unit box, we're not actually passing any UV values. So they are defaulting to 0, so they are pulling off the very top of the top corner, top left corner of the texture. In that case, it's brown. In this case, can't see, but it's red. For this one, it looks like it's black, but but it is actually showing up red as it was. And that actually is because after playing around with the adding in some of the filter, playing around with filters, and then changing this to adjust the UV a little bit. Let me. So yeah, back to what I was saying. So yeah, while we were expecting this to be brown, or black, it was actually showing up as red, and that's because by playing with and adding a UV value there, I ended up getting getting this, and that kind of showed that there is actually a red outline apparently around this. You can see it. It's there, and so that's what I ended up getting, and just setting a UV to that kind of made that obvious. So for further work 2, I've created the 10 by 10 by 10 grid of cubes, single model, multiple matrices, basically just a triple for loop, and this is the basic pre-computing the view product, and basically the color selected 3D optimized that we did from part one. Um, and that runs at about 267 frames per second was about what I was getting. And changing that to say, um, sending the context here will almost cut about a third off of it. So it'll be down to about 180 frames per second or something, versus say uncoming that out and forgetting to send, like I did, and forgetting to send the updated matrices once, and I saw that it jumped up to 400 frames per second. It's basically doubled. So yeah, there's a lot of different options that can affect it. And so that's about it. The only other thing I want to mention real quickly is that, yeah, I got the sphere done. So there's that.